So, hello everyone. I hope you can hear me and see my screen. Welcome to the Let's Build tutorial. You should be able to unmute yourself. I will also have here a little look at the chat window, but please, if you have any question during this Let's Build, just unmute yourself and ask the question directly, probably easier than going through the chat. So during this exercise, map CDA to FHIR and back, I would like to show you what I have presented yesterday so that you see that this can be done in real, not only on slides. You have here in the documentation the link to the exercise, which is actually just a PDF which refers you to the tutorial which is on GitHub. So we go here to the tutorial. So what we will go through together is first we will try to validate the CDA document. Then we will convert the CDA document to its JSON representation, how it looks like from this FHIR CDA model. Then we will apply a Firepass expression to the CDA document. And then we will transform CDA to FHIR with the FHIR mapping language. So what is essentially needed is that you can run Java. So otherwise you will not be able to follow this tutorial. And the second thing is that you have the happy FHIR Java validator available. We have a little bit of a challenge today because for those who are just setting up right now is that the link where we normally download it from the Confluence page is broken. So the Java validator is here. Oh. So, and you have here the download link, but that doesn't work at the moment because the latest release is not included. So you have to download it from here. So this downloads the previous version 5.1.2.2. So please download it here to get the latest version. Okay, so I quickly go here if there are any chats. No, then let's start. So there is one chatted here. Can you please share a link in the chat? For sure, here you go. So this is the link to the tutorial. If you want to follow along completely, so also with the editor, if you don't want to do it by command line, so you need to set up Visual Studio Code if you haven't done this yet. There are two clients here, the REST client extension for Visual Studio Code, which we can use, and the FHIR tools extensions. If you need a step-by-step introduction, I think there is is here the setup slides. So you see here how you can do it if you are not familiar with Visual Studio Code. Installing here the REST client. So you enter REST client in this extensions tab, and then you can click here on the install button. And equivalent for the FHIR tools, you in this extension tab here, you add FHIR tools, and then you get it here. I put you that link also into the chat. Okay. So First step, here I download here. So the first thing is what we want to do is we want to validate this CDA document. You can maybe take a CDA document on yourself, but this one here is one that I used for the exercise. It's one we use in Switzerland. And what we can do now is you then can call the validator and do the validation with this to validate it. So there are two ways of it. So the easiest, or depends what you consider as easiest, but if you have the validator downloaded, you can just start it with Java and provide the path to the jar. Then you add the document if you have downloaded it. You specify the version. So we are working with FHIR version 4. And then you have to specify the implementation guide. So this CDA core model, I made a release here so we can directly access this implementation guide. This is, it's not an, it's the same as an NPM package. So you refer it directly from here. If it would be published, we could also add this publish name. So this use it, you can also download this package, and instead of referring it by HTTPS, you can directly use this package. So I'm going back here to the terminal and I add the parameter here. So what this will do is this should now start up the Java validator. You see here the version which you are using. So this is this 5.1.22. When it was the last time built, it loads the, because we specified the FHIR version 4. It loads up this package, it loads the terminology service, and then it loads the package where we have the CDA Logical Model. And then you see here the results. So we have 0 errors, 0 warnings. Then the second possibility, so if you have, here is the CDA document, you can also call out the validator from the VS Code. So here you have FHIR validate resource with params, and then you can add here these parameters. So this is actually the same way, but if you install that today, the VS Code extension was not possible to get to download this Java validator due to this hiccup. So you would have to fix it manually, copy that manually there if you want to use it that way. So this is the note here. You would need to copy, if you download this validator client point jar. So sorry for this mishaps. You have to copy this in the VS Code extensions directory if you have installed this. Are there any questions about validating this CDA document? Oh, I don't hear you. Sorry, you sound very far away. So what is the version of CDA document, 1.1 or 2.1? I think this is CDA version 2.1. So I'm not, are there CDA version 0.1? Alexander Henkert. Michael, are you on? Alexander Henkert would like to be unmuted. Can you do something?
Yeah, I apologize for whatever reason that it is not allowing me to mute or unmute. So
I'm currently unmuted. I was just wondering if you're expecting audio to be in the call and people asking live questions, then you should be able to unmute.
Yeah, good. So you can. Can you answer the question about 0.1 and 2.1 CDA?
Well, I'm assuming that there ever was a CDA 0.1. I don't know that CDA 1.0 is even relevant these days. There is a CDA 2.1 as of recent. I do not know that the FHIR Logical Model that you count upon during this tutorial has been updated for that. But as soon as it is.
This particular example, the radiologist said, take parathyroid, for example. We do more than any other clinic in the country.
Oops.
I have to beg and plead for surgeons to tell me what they actually found. Out of the more than 500 studies I do each
Maybe the mute button is not so bad after all.
That's less than 1%. Imagine.
Who is it? Do we see that?
Andre keeps coming up whenever the sound is intruding. Anyway.
So CDA 2.1 was released recently in that case, Alexander?
Yeah, somewhere last year, I think.
Okay, so the logical model was not updated to that, I would say, or at least I didn't follow up this.
True, I think every effort went into making sure the logical model for 2.0 was exactly right, because once people start building off it like you are, you cannot have a logical model shifting. So I guess that's where all the effort went, and 2.1 is on the to-do list.
Okay. So thank you for the question. So we are based on 2.0 in that case, and we will need to look at actually what the impacts are, because our nation, especially in the context of Switzerland, I think we are based also on 2.0 and not on 2.1. So
a little reassurance there. Every effort was put in to make 2.1 backward compatible with 2.0. Okay. There were few instances where that was impossible. One of them is language code, which was CS in 2.0 and is CV, I think. It might be CE even in the newer versions. So it's wider, and you can now specify your own language codes. It's tiny things like that, really, really tiny.
Okay, good. So I take this up for discussion here. Thanks for explaining this to us. Has anybody else a question about validating the CDA document? Because otherwise I would continue. So doesn't seem to be the case. So what I would like to show you now is just the next step. So we convert this document to a JSON representation, and the validator can also do that because it has a way of specifying that you convert it. So what we add is just that this convert option, and we say we want to have it in this output as this JSON document. So I do that. Oops. Huh. Oh, something wrong. This appears not to be a FHIR resource. I didn't specify the IG. Okay, so now we have converted it, and we see the result here. So you see now here, so you have the resource type clinical document, realm code CEE. So when you look here, we have exactly the same information, but it's now converted to a kind of JSON representation here. Type ID, root, extension, we have it here as attribute. Then we have here the template IDs specified here in this array. Okay, then what we want to do is now to execute a Firepass expression. So Firepass is this possibility that you can extract data like XPath in XML. So maybe Alexander can tell the differences.
Well, maybe on the previous subject, how do you know what to convert with? I believe you had a previous talk where you were talking about all kinds of maps. Does the conversion know what to use?
So this is no conversion. That's a bit a difficult thing to think about. This is just the JSON representation of the logical model, and there is absolutely no conversion.
My bad.
So,
sorry.
No, it's really, I think it's thank you for asking the question, because this is really something a bit too very hard to grab in your head. So if you have a logical model, you can have the logical model represented as XML, and then we have the clinical document. And
in three terms, you have a new ITS representation.
Yes, probably. Yeah. So we have now a JSON representation of a CDA document according to the rules of the logical model. So, I mean, the only thing which this is actually helpful is we see this with this Firepass query afterwards, because this Firepass query works now on the logical model. And so we can go in this clinical document. So this has nothing to do with mapping, can apply a Firepass expression. So I want to extract here the family name or the given name. So this is going from the clinical document into the record target, patient name, family. And I can do this now here. So if I'm lazy and I'm copying in this, so I'm giving here this Firepass string inside and adding these arguments here. So, oops. So this should return me now the.
So Oliver, there's a question in the chat if you want to look at that. I'm not sure if Osm can unmute.
It is using default logical model when converts to JSON, or do you have any specific for CDA? Yes. So this is exactly the thing it's doing, because otherwise it wouldn't know what to do. So if you convert that to JSON, it converts to the JSON representation of the logical model. Yes. I hope, Kurt, if I'm spelling this correctly, that this is answering the question. Otherwise, please add it in the chat.
I have a query here. So in
Yes.
CDA, we have different templates. So this logical model, is it going to work for each template or just this medication one?
So the logical model, I show you quickly here. This is working for every CDA document. And this, what I'm showing you till now, is also working for any CDA document, because the CDA logical model has nothing to do with any templating thing. So this is just the base CDA logical model. Might I have it, maybe the link in here. So when we go back here, this is the this copy paste didn't work. So what you see here, this is the logical model. So we have a clinical document, then you have the differential table which shows you how this clinical document is represented. So we have a class code attribute, MUD code. Then you go into the component, or now better not to go into the comment. So we look at with the record target. So you have the, where is it? Record target here. So it tells you in a CDA document, you can have 1 to star record targets. Then if you go into the record target, you go into the patient row. And you see the templates ID here. But what we are doing now, we are just using this logical model description of a general CDA document. So this is no, is not concerning any templating yet.
Okay, got it. Thank you.
Hi, this is Özlem. I think my question, I think you kind of answered, but you know, when we view, let's say, CCD, we refer to XSL, so we kind of, you know, follow its structure somehow when it converts to human readable, you know, HTML. Maybe we missed or didn't see how does it know that it's supposed to use this default CDA model? Like, where do you inject it, or do you have to do anything special that will understand it is not any type of XML, it is a CDA type of XML? Like, where do you indicate that?
Yeah, so this is the CDA model is the source of it is here in GitHub. Oh, I'm so bad at copying. Excuse me. So, here, there's a come. So this is the source where this model is described. If somebody makes a change, this will be built up here. So this is the continuous integration build. And one output is the implementation guide, what we see here as the clinical model. And the other thing is that you get a package with it. So the package, this is like the NPM package. So if this model will be released, then you have here the package name, package HL7 FHIR CDA star 2.1.0. So this is the current version. And you have to specify this model when we do this operation that the validator know this implementation guide. So what we did for this tutorial was that we, instead of using it here with this package, we specify the package directly. And this is because we have made some small changes that it was working with the medication. So this is here up this. So this link here, this indicates you the CDA logical model here, which we released for our project. But you could also specify, we can try that out now with the validator. So if you want to just use this current build of the logical model, you add this here. So this is this IG parameter you see here. With this, we specify which additional implementation guides, or this can also be a logical model, we add here. So what this does now, it loads now up. I'm hoping the package server knows this model. And he goes searching for it. And what you see here now, and I think that's because it's not officially released. So he tries to read it, and you see here it's an error message. He tries to read it from this URL.
So does that mean that if you load up this package, it will recognize anything in the v3 namespace with a root element clinical document as being an instance of that logical model?
Yes. that's correct. That's exactly that. So what we do, you can add here, you can do this for every implementation guide where here, where a build is, you can go take this away and add here package point tgz. And this gives you the, is the complete description of the logical model inside. And afterwards, like Alexander told, the validator knows how to handle CDA documents. So that's how the validator knows it. And actually, you could add any other logical model. So there are logical models for V2, logical models for any structure definition, and this one is the logical model for CDA. Sorry.
That's perfect. Thank you so much. Makes
Okay.
a lot of sense. Mm-hmm.
Perfect. Thank you for the question. And so that's the nice thing. So we can, till the end, go through all the steps and understand what it's doing. So what we have seen here is, so now because he knows this logical model in this case, he can now go inside and evaluate this expression. So you go here, record target, patient role, patient name, given data string, and it gives you back here the Monica name as expected. And what you see here, you can now do the same. Here we have kind of a Firepass viewer. You can also use, now it's hidden, sorry. So you can also copy this out, this JSON representation, and use Nikolai's Firepass web viewer or any web viewer. And here you can now like just go into the tree. So if I go to record target, I see I've now selected here my record target element. I enter patient role. So I'm at the level of patient role, and then I see the patient. So I get the result back, what is in the patient object, name, family. And then you see, we wanted to have the given. You see that you get here to Monica. And this is also a bit that you have here to add data string is a bit the peculiarity of the CDA logical model, because when we look at the representation here, this is a V3 data type. So where will we record target? Then we go down to the patient role. Then we go to the patient. And when we have the patient, we have the name to the EN data type. And when you look now, the given name is of data type 0 to star ENXP. And here, this is derived from ST, or we look at the snapshot table, and then we see here that we have this, we would go to the XML, this data type, the string type, because this data is inside. This is a bit how this model is defining it. So you look here inside data string. Now we have to go one deeper because, no, why do I not see this one here? Should be in the snapshot. We should see an XML text. So yeah, so we see here that we go here in the XML type, and then you have this type code string for this data type. So this representation here helps you a little bit, this JSON, that when you are suddenly not finding the data which you have, then you see how it is represented in this logical model.
As you were clicking through the trees, I noticed that the V3 ID is not rendered. Did we ever get through that issue?
No, I don't think so.
So patients are ID-less?
No. So wait. Maybe it's not rendered, but it's in the model. So there is so there is an issue. I think this is the IG publisher, that because the ID element is defined by FHIR, and this gives a problem with logical models because we have also an ID element there, but this has been solved that we derive the logical model from the base element. But so the ID element should be inside.
So they followed your proposal.
That was not my proposal. I think Graham introduced this base class afterwards, which is now, and this is a bit in between because this is a release 5 kind of thing, but the tooling supports it. Yeah, so this ID extension element stuff is solved. That's cool. That's a good thing. Good. So now we have everything ready to go. I go back to the tutorial to map now with the FHIR mapping language. So and here now this is specific for the mapping is now really specific, which goes down for this example on a mapping level. And maybe I show you how it looks like just in the GitHub repo. HL7 CDA FHIR maps. So we also want to construct it as an implementation guide, so that later on you can upload all these maps like implementation guide. And we have here now the maps in here, so I can also put this into the chat if somebody would like to follow up. So we have all the maps which do these mappings here, and so you have for example here CDA to FHIR types. So this came originally from the CCDA project, and here you see now different mappings, how these different types can be mapped. So for example, how the EE type is mapped to an identifier, and how an int type or a template ID type is mapped. They are not 100% complete, so there could be things that there are things missing. But at the moment, we are just enhancing them as we get with our CDA back things to problems. And
what does
so
it
this
do
is
for OID URI conversion, or is that one of the unfinished bases?
OID to URI conversion. So
oh, there's a concept map, I see.
Yeah, so there is a concept map. There is one concept map which is defined by FHIR itself, I think, where you have, so it's using this one. Let me see, this is, if I'm not mistaken, this is.
There was a quote in front, yeah.
Yeah, thanks. So.
Maybe HTML added.
But that's a strange error. So he can't resolve. Is this? This is. I guess this is an internal map, maybe. So, but at least yes, there is some conversion done because you need to if you want to convert the OIDs to the correct HTTP equivalent. But this needs to be adapted for the use case, I guess. So I need to check if this was, I think if this was an internal concept map which is used, or if it's from the specification. And you see equivalent also, for example, the contact point is a bit different. So you have to check what kind of different contact points you have and what kind of different users, and you then try to map it accordingly to the different FHIR types concepts. And then the next step is that you have a CDA to bundle map, where you, for example, here we just, you see we are missing the unknown and the other, but here there is also an embedded concept map where you have the coding which can be translated, and then it goes through these templates. So you go from a clinical document to a bundle. So in the bundle, we create a composition, and we create the UUID or the ID, we append the full URL, then we create a patient, and then we go into the bundle. And in the bundle, we specify that the bundle times type is equivalent to the CDA effective time, and then we go through the body and start matching this section. Now first to the composition, excuse me, then that would be the next step. So composition, so here this is this header level template. So we map the language code, we map the identifier, the status, then the title, and then we go down into the record target. What you then need to do is, we are now going like in the CDA tree down, but for this we have to create the entry in the bundle. So you create the reference, then inside, and then you add this patient in the resource in the subject. But the important thing is now, if you want to use these mappings, you don't have to know about all these mappings. So this is part of the authoring part. You have to develop the map, you have to test them, and then you have to convert them to a structure map, assemble them, and then, like we have seen before with the CDA Logical Model, you get an implementation guide out of it, where you have all these conformance resources inside. So this is then this CDA FHIR Maps, and we can use this package, and then the Java validator knows all these resources to transform, and then each map is identified by a URL, a canonical URL. Then we can specify the canonical URL which we want to use to transform the map. So I try to show you how this works now. Add this one here. So with this address here, we are adding now from this FHIR maps, all these maps which are necessary. With the transform, we specify that you want the transformation. We use this canonical URL which specifies this map, and we say that it should be output as a bundle in here. Then I execute that here. So that's this. So this will load now up and do this transformation. What you see now is that first, since we base our maps also on the Swiss implementations, oh, that's a whole lot of logging output. We'll also load the dependent maps, and what you see here is the output of the logging of the FHIR mapping language itself. So it goes through, it tells you if you have any problem, you can try to follow up and go there. And what you see now is you have here our bundle, and we have here now the the identifier. We have now the composition resource with the different entries inside. So we should have a title here where we have the title, we have the confidentiality pole, and we should now have our patient as a patient resource, and he's called Monika Wegmüller, with here some encoding problem still. So this is one way of doing it, executing the maps. What you soon will know is that this is quite a bit slow because it's not very interactive. How we used it now mostly is we are putting this logic up in a server, and then we start up the server and use the transform operation. So what I'm doing here is on this test server here, I have this transform operation implemented, and this is a HTTP request. So I'm sending it exactly the same document here, sending it over HTTP over, and then I have the response here with the bundle. So this goes a bit faster because the validator has to load all these packages and stuff, and if it's preloaded, it goes much faster. And the equivalent, we work this also when we are developing the map. So we have a authoring function on the server so that it can convert the textual map to the structure map transform, so you get a bit more interactive. Do you have any questions?
The response time you got from the server was a little over a second, which is pretty good. Or
yeah, I would say so. This is pretty good. Yeah, I would say. Yeah, but it's honestly
well, it's pretty good compared to the command line where it had to load all that. But it's not near what you could use for production. Do you see us getting there?
Yeah. Honestly, I see a bit an issue there at the moment. So I don't know if it's yet an issue. I started working with bigger documents where we have, and we saw we have over a second's converting time, and this will not be acceptable by the customer. So we have to investigate a bit where we are losing time. So yeah, I think this should be something which should be in the, I don't know, 200 milliseconds area and not in seconds area. Or what would you expect, Alexander?
Well, for production, I would assume yes. I think the initial work went into getting it to work at all, probably. The mapping language definition, the tooling around it. So maybe now it's time to start tinkering on performance.
Yeah. So I think we are even at the moment a step before evaluating the performance yet. But yeah, afterwards it will be definitely a performance issue because I think, I don't know how many CDA you have in the Netherlands. I mean, here we don't have yet a performance issue, but it could come up soon.
I first need a use case to actually build a pipeline for this, and then I'll start crying first because I need to create those maps.
Yep.
And maybe, I don't know in which talk you alluded to that, but creating the maps and testing those and making them foolproof and clinically safe is probably where lots and lots of work gets into.
Yes. Yeah. I mean, there is, I think this year, I didn't see a FHIR mapping language track. Last year there was one at the DevDays, and at the Virtual Connectathon there is also a mapping language track. So if you're interested in working with the mapping language, I think then it needs some ramp up time, and There is also still some development going on. So yes, this is definitely a hard topic. So it's not the easiest language, but if you get, I think as soon as you are a little bit into it, it gets then easier. How to make it clinical safe? I mean, that's a very interesting discussion. I think it's depending a little bit on the use case then also, but yeah.
Likely. Do you use it to expose heaps and heaps of documents in XDS environments to FHIR clients? Is that how you use it?
No, actually we would like, or we have to use it between on a document level, not even on a data level. So we follow in Switzerland the IHE pharmacy way, this CMPD profile where they have 6 different documents, and there is some resistance from the implementers to use this in CDA, so they want to have the FHIR version. But we have also systems which generate the CDA. So, but the legislation is not yet through. So at the moment, it looks like we will have to live with both worlds. But this will be also a bit depending. So at the moment, we have systems which are really producing CDAs and systems which are only reading FHIR.
Interesting.
Right. Any more questions? So I think I didn't get a warning this time, but I think we are up in time. Alexander, if I'm allowed to ask a question, can you maybe tell, is there any development going on since we talked the last time about exporting structure definitions based on the logical models in Art Decor?
No, is the short answer.
Okay.
Doesn't mean we couldn't revive it because the demand seems to be coming back. But you were talking about exposing our Decor defined template ITS as profiles based on the CDA logical model. So you could do you could move your profiling efforts from our Decor into something else. FHIR based, that is. Yeah, no, it has to be revived. It hasn't been touched since
last year. Okay, so there was one question from Cedric. I'm not a CDA expert, but I remember that CDA templates can be closed or open to extension. If closed, the mapping defined can be sufficient, but how do you manage the open cases where any content can be added in a document? Yeah, you can't, in short. So if you have open content and in your template and
it's one of our issues actually. We have a gazillion extensions for medication dosage. So we have different data types from the rest of the world, I suppose. And we have a couple of Dutch extensions. You have IHE extensions. There's SDTC extensions. So you will need to create a new logical model, I think, for each of those.
Yes, yeah, that would be the, if you want to use the mapping, I think you would need to add this. Yeah, and I say especially because, we had to add the farm extensions, which also extend the CDA model also into the logical model. Yes, that's correct. This is a bit limitation that you cannot add additional. But as soon as you have it in the logical model and you know what kind of extensions you have in your project, you're able to map it. It's just that you cannot map the unknown open content that is, but even also if it's closed and you don't map everything, then you don't have everything mapped. Yeah.
Does the mapping ignore what it doesn't know, or does it error out on extensions that it doesn't know? I.e., could you have a graceful fallback?
at the moment it is just ignoring. So the mapping maps what it is able to map. Or
So
you would have to introduce an error. No, it's, yeah.
it's probably a good default, but there might be a need for an option to explicitly error out on unknown content.
Yeah, yeah. And he adds a question, or maybe a way to add an extension possibility on the FHIR mapping so that CDA source can map their own content. That
would be a defect in the V3 methodology. I think you cannot invent extensions after the fact.
Yeah, I think honestly, I mean, what I could imagine also is that maybe at one time that you would have a basic CDA to FHIR mapping, which maps you just the bundles and sections, and maybe you write some additional mappings to have your specialities then included. But yes, we look how it's going. I think it's not, I think that's where a lot of people are a bit disappointed. We have not a general way of mapping CDA to FHIR bundles. So you will have to work on a template level. You will have to work what is clinical safe, how you extract the information. So it is really work and not just something which comes out of the box for free.
Just not so weird if you realize that there are many implementation guides with very varying quality out there, combined with even more varying implementation quality. So if you try a general purpose CDA to FHIR back and forth, you're disregarding the level of maturity there is around the world.
No. Okay, so yeah, that's also a good point. Yeah. Okay, so I think the host who should end the meeting disappeared. So I will end this meeting. Thanks a lot for your attention. If you have any questions, do not hesitate to contact me. Thanks, Alexander, for contributing to this Let's Build session. This was not planned, but was very nice of you joining and asking questions and explaining. So
Sure,
hope to see you. Thank you. Okay, goodbye, everyone.
Thank you.